Okay, this is the introduction for lab number 16, which is about Hooke's law, and essentially what we take a look at elastic systems, where we take a look at springs. So go ahead and pop that simulation up, and some things we know about springs is when you apply a force to them, they're going to stretch. Well, how far are they going to stretch? Well, that depends on a couple things. It depends on how much force and how stretchy a spring is. So this is going to be the force we have to apply to a spring. This is going to be a spring constant, which is a measure of how stretchy a spring is. If that spring constant is relatively small, the spring's going to be pretty stretchy. If it's high, the spring's not going to be very stretchy. And this is how far you stretch the spring from the equilibrium position. So what we're going to do is we're just going to apply a force to a spring, and we're going to push it, and we're going to pull it, and just make some observations. Then I'm going to have you set a force on that spring and mess around with the spring constant and kind of see what that does. Then what we're going to do is I'm going to have you set up a spring and apply some forces to it and measure how far you stretch it from the equilibrium position. And again, we know that the spring constant would, from Hooke's law, be the force divided by how far you stretch it. So you're just going to calculate that guy just right there. Kind of what we do from there is I'm going to have you play around with a couple more springs, and then I'm going to have you go into a systems tab, and you're going to set up some springs that are in parallel, and you're going to set up some springs that are in series, and you're going to do the same thing. Apply some force to them, measure the displacement, calculate the force divided by the displacement, and kind of ask yourself, which one would you expect to be more stretchy? Would you expect that one to be more stretchy than that one, or vice versa? And the force divided by the displacement, the spring constant, is going to give you a number for that. So let's go ahead and pop open the simulation real quick. So when you pop it open, you're going to have a spring, and what you can do is you can play around with the force. You can kind of see playing around with the force is going to stretch it. You can also kind of play around with the spring constant. Now, that's not very useful until we actually get some values here. So now you can kind of see I have some forces, and I have my displacement from the equilibrium position. So pretty straightforward. You kind of play around with those and fill out the table. And the systems tab is right down here, and you're going to do the same thing. You're going to get the forces, so you're going to get the displacements, and so you're going to apply that force, measure the forces, measure the displacement, take the force divided by the displacement, and you're going to have the spring constant. And we can do springs in parallel or springs in series, pretty much the same thing.